Hi there. Here we are back again for another bunch of definitions. These hopefully will be a little bit more practical than the last set. I know those were very tough. So let's just dive right in. If you're following along in the textbook, we're looking at pages 84 through 88. And the first term is activation energy. And this is the energy needed for two colliding atoms or molecules to react. A catalyst is a substance that reduces, or I'm going to say lowers, activation energy so it lowers the energy needed for this reaction to occur, and speeds up a reaction. We're going to look at examples of these, so I'm just giving you the definitions for the moment. A chemical change is a change that results in at least one new substance. And here's an example. If I am baking a cake and I add the eggs and the milk and the flour and the sugar, and I put that in the oven and allow it to bake, once the cake is done, can I go back to eggs and flour and sugar? No. That is a chemical change. Once the change has occurred, it can't be undone, or it can't be easily undone. Here's another example. If I pour some liquid water into ice trays and freeze it, can I go back? Well, sure I can. I'll just take the water out of the freezer and allow it to melt. That is not a chemical change, because that one can be easily undone. That's called a physical change, and we'll get that one in just a minute. A chemical equation shows the formula states of matter and reactants and products in a reaction. And I promise you we're going to look at this in more detail. I just need to give you the terms. The chemical equation, we are going to break that down and understand how to read one of those. A combination reaction is a reaction that forms a compound. And I'm sure you're thinking, why does she have this marked with a yellow star? And we will find out in just a minute. So just hang tight with me on that one. That's not an accident. A decomposition reaction is a reaction that breaks down a compound. Remember when we talked about the carbon cycle and we talked about the dead bird in that picture? That's decomposition. It's breaking down the compound, which in that case was the bird. Or the bird is a bunch of different compounds all mixed together. Okay, endothermic and exothermic. These are important. Endo is one of our morphemes, and so is exo. So let's go back. Therm is also. So let's go back. If we know our morphemes, we can read this. So let's go back to the morphemes page and take a look. Let's back on page 4. Okay, here's therm. That's heat. Maybe we don't have endo and exo. Yes, there's exo, which means out. Do we have endo? We do not. So let's go ahead and add endo to this list. Usually when you add exo, you add endo, but that's okay. Endo means in or inner. So the morpheme is endo. Endo, exo, and therm. So let's go back down here to our page. Here we go. Endo, which means in, and therm means heat. Heat, therm, is internalized. It goes to the center, the inside. But the surroundings get cooler. So the heat is sucked inward, leaving the outside, the outer edges cooler. Okay. Exothermic. Heat goes out. And what happens when heat goes out? Let's think about it logically. If heat goes out, the inside cools, and the surroundings get warmer. So those are opposite, inverse reactions or actions. With endothermic, the heat goes in. With exothermic, the heat goes out. So if you know what endo and exo mean and you know what thermic means, you've got this one. Okay, let's move on to law of conservation of energy. And you notice that this one is capitalized. It should be. And this simply says, and it is pretty simple, energy cannot be created or destroyed. It simply changes forms and gets recycled. And when we break down a formula, you will see how this works. Energy cannot be created or destroyed. A physical change. This is like the ice cube that melts. It is a change that does not change the identity of the substance. So let's go ahead and get this written down, and okay. So think about the ice cubes in the freezer. They're water in a solid state. I take them out, set them on the counter, and that water melts. That ice melts down into liquid water. It's still H2O. It still tastes the same. It's just that I can drink it, I can swallow it, or I can chew it up as ice. But it is the same substance. So liquid to gas and gas to liquid and solid to liquid, those are physical changes. They do not change the fact that your chemistry is H2O. Okay, the next word is products. And this is the end result of a reaction. The end result of a reaction. Okay, so when we do our formula in just a minute, it's going to be the end result of the reaction. The reactant is an ingredient in a chemical reaction. So this is the stuff that you put into your chemical reaction. And again, when we do an example, we're going to use all of these terms. So hopefully, or most of these terms, hopefully you are going to see how all this fits together. The reaction rate is how quickly or slowly a reaction occurs. Some of them go quickly, some of them take a while. So that is the how quickly or slowly a reaction occurs. Okay, a synthesis reaction is a reaction that forms a compound. Where have I heard that before? A reaction that forms a compound. Well, it's a combination reaction. Those mean the same thing. They're exactly the same definition because they're the same process. So the books can call it synthesis, they can call it combination, but it means the same thing. Okay, I want you to go ahead and write down something for me. Just copy what I'm doing here. We're going to say 6 CO2 plus 6 H2O. We're going to draw an arrow, and above that we're going to say light energy. And then we have C2, I think that, oh, never mind, C2H12O6 plus 6O2. Okay. And I want you to write this question. Is the equation balanced? Now, if you know the answer to that and you know why you know the answer, you can skip the next video. But if you don't know the answer to that, we are going to look at that formula with a visual picture in the next video, and we're going to figure out whether or not this equation is balanced. So this is where all these terms are going to come together, and you will understand what this formula is saying to us. So I will stop this video, and I will see you in the next one, and we'll do another little project instead of just writing terms. So have a great day, and I'll see you very soon.